Welcome to Keentel Engineering. This video is a developer's roadmap through TVA's large generator interconnection procedures, from the initial interconnection request all the way through studies, the LGIA, and commercial operation. Whether you're developing solar, wind, hydro, thermal, or battery storage, the same LGIP framework applies to every generator above 20 megawatts in TVA territory. The TVA LGIP governs how large generators connect to TVA's high-voltage transmission network. The 20 megawatt nameplate threshold is the dividing line. Anything above it follows this process. The framework covers 4 areas: interconnection request procedures, the cluster study process, engineering and construction provisions, and withdrawal and termination rules. While the LGIP aligns with FERC pro forma standards, it is tailored for TVA's specific grid conditions and regulatory policies. 2 parties carry defined obligations. The interconnection customer, the developer, submits the Appendix 1 request, provides technical documents, site control evidence, and the required deposit, funds all 3 studies, and meets every Appendix B milestone. Restudies and withdrawal costs also fall on the developer if applicable. TVA conducts and oversees all interconnection studies, sets and enforces milestone schedules, builds or supervises interconnection facilities, ensures NERC reliability compliance, maintains audit rights after commercial operation, and applies withdrawal penalties and termination clauses when triggered. The process runs in 4 phases. Phase 1, submit the Appendix 1 package. Project specs, megawatts output, point of interconnection, fuel type, site control evidence, and the required deposit. Indicate whether you need capacity interconnection rights or energy-only service. Phase 2, the scoping meeting. TVA reviews the configuration, defines study assumptions, classifies the resource, and confirms point of interconnection feasibility. Phase 3, the cluster study. Feasibility, system impact, and facilities studies run in sequence, with a restudy if assumptions change. Phase 4, milestone management. Appendix B governs every date from design through energization, synchronization, and commercial operation. 3 studies, all developer-funded. The feasibility study is a high-level risk screen, identifies major constraints, approximate upgrade requirements, and any fatal flaws, includes power flow screening, voltage and thermal screening, and an early cost range estimate. The system impact study is the full reliability analysis, N1 and N11 contingencies, stability, short circuit, and voltage impact across the cluster. The facilities study finalizes detailed engineering designs, confirmed upgrade specs, and definitive cost and schedule estimates, substation design, line ratings, protection upgrades, and construction schedule. Developers pay for restudies triggered by assumption changes and for all withdrawal costs if they exit after studies begin. 3 execution models govern how interconnection facilities get built. Model A, the standard option, is the most common. TVA handles all design, procurement, and construction. Developer pays all costs but has no construction management role. Lowest risk, but limited timeline control. Model B, the alternate option, TVA commits to specific delivery dates with liquidated damages if it misses deadlines. Stronger schedule protection for the developer, limited to Appendix B scope. Model C, the option to build. Developer builds TVA-owned facilities under TVA oversight using TVA-approved engineers. Milestone responsibility transfers per Article 5.1.3. Fastest path to in-service date, but developer assumes full construction risk. The pre-COD milestone sequence follows 5 steps in order: design complete, facility energized initial synchronization, performance tests, and COD achieved. Commercial operation cannot begin before initial synchronization. That sequence is fixed. Post-COD obligations continue for the life of the agreement. SCADA and telemetry must deliver real-time data per Appendix G. Revenue-grade metering is required, and TVA retains audit rights at any time. Protection settings must remain TVA-approved, and NERC reliability compliance is ongoing. The LGIA term is 20 years, auto-renewed annually unless either party gives notice of termination. Several LGIA articles directly shape developer risk. Article 5.1.3 enables the option to build. Article 16 covers force majeure. Article 18 is the insurance, indemnity, and liability framework. Article 22 governs confidentiality of study data and LGIA terms. Section 3.7.1 defines the withdrawal penalty schedule and the 90-day voluntary termination notice requirement. Key appendices. Appendix 1 is the Interconnection Request form. Appendix B governs milestones and financial obligations. Appendix E covers commercial operation, backfeed, synchronization, and COD. Appendix G defines SCADA and telemetry requirements, including low voltage, ride-through for wind. Appendix H documents operating assumptions for energy storage. Missing milestones or regulatory violations can trigger TVA suspension or termination and recovery of all incurred damages. 5 case studies show these rules in practice. A 100-megawatt solar farm in Middle Tennessee hit all LGIP milestones under tight deadlines and reached commercial operation in 24 months. A 50-megawatt wind farm built SCADA and telemetry to Appendix G standards, passed TVA performance testing, and entered commercial operation on schedule. A developer at risk of missing facilities study milestones restructured the schedule with TVA, stayed in the queue, and avoided penalties. A cogeneration facility that canceled its LGIA managed the termination carefully and recovered 40% of prepaid costs. A developer needing validation of TVA's cluster study modeling assumptions got a PSSE model review that improved accuracy and ensured fair cost allocation. How long is the LGIA effective? 20 years, auto-renewed annually unless either party gives notice. What happens if milestone dates are missed? TVA may assess withdrawal penalties or terminate the LGIA. Appendix B governs the schedule. Can a developer build TVA's facilities? Yes, under the option to build per Article 5.1.3 using TVA-approved engineers and contractors. Who pays for network upgrades? The interconnection customer funds all network upgrades and interconnection facilities. Can commercial operation begin before synchronization? No. Initial synchronization must precede the commercial operation date. What are standalone network upgrades? Upgrades that can be constructed independently without affecting day-to-day transmission operations. What is Appendix H used for? Documenting operating assumptions, especially charging and dispatch schedules for energy storage. What are wind-specific interconnection requirements? Low voltage ride-through compliance, power factor support, and real-time SCADA per Appendix G. Interconnecting a generator with TVA isn't just an engineering task, it's a compliance lifecycle. From the initial Appendix 1 submission through feasibility, system impact, and facilities studies, every phase is developer-funded and milestone-driven. Miss a deadline and you risk penalties or LGIA termination. Choose the wrong construction execution path, standard, alternate, or option to build, and you inherit the wrong cost and schedule risks. And once you're in commercial operation, TVA's audit rights don't stop. At Keentel Engineering, we've taken projects from first scoping meeting to COD and secured 40% cost recovery when one had to exit early. For more information, visit KeentelEngineering.com.